Okay, welcome everyone. We have a test coming up here in Chem 151. So what I'm going to try to do today is go over the sample version of an Exam 1 test. You can find this exam, practice exam, on your Moodle site. I would highly recommend that you try out the practice exam first before you watch the video. That way you can judge how prepared you are for the actual test. And then, if you still have any questions, you can watch the video to kind of maybe see what direction you need to go in terms of getting to the point where you can answer all the questions on your own, just with your periodic table and your calculator, because that's how things will be on the test. Now, looking at the first question shouldn't be much of a surprise. We've got a question here on naming. So we've got four molecular formulas here where we want a name, and then four names where we're going to want a molecular formula. So looking at the first one, RB, that's rubidium. So make sure you find it in the periodic table. Rubidium is actually in column 1 in the periodic table. It's underneath lithium, sodium, potassium. That means it is always going to be +1 charged, and we don't want to say that it has a +1 charge. It's just based on its location in the periodic table, it is just understood. So our cation, which in this case is a metal, is rubidium. Our anion, sulfur here, based on where it is in the periodic table, we know what its charge is. It's -2. That makes sense if there are 2 +1 cations there. But because we don't need to specify charge for rubidium, the name here is just rubidium sulfide. So make sure you change the ending of sulfur to IDE, since this is the sulfide ion in the molecule. No charge. Don't show a charge for a metal in the first column. Now the second one, niobium, that's a different story, because if we find niobium on the periodic table, so it's atomic number 41, it is in the transition metal series, and we know transition metals, we need to specify what the charge on niobium is in this compound. So to get the charge, we're going to look to the anion. The anion here is oxide. So we find oxygen on the periodic table, we can recognize that it's going to have a -2 charge when it's in its anionic form. So if each oxygen has a -2 charge, and there's 5 of them, 5 times 2 is 10. So we've got a total of 10 negative charges from the anion part of our ionic compound. That means there must be 10 positive charges from the cation part, or in this case metal, part of our ionic compound. So if I've got 10 positive charges, but those 10 charges are spread over 2 niobium atoms, since there's a 2 there, subscript, 2 niobiums in the formula, we would describe that as niobium 5. So each niobium atom here has a +5 charge. So this would be niobium 5, so Roman numeral 5, oxide. Okay. Now the next one is all polyatomic ions. So this one can be tricky, because you might look at this one and think, oh, those are all nonmetals. That means I'm going to name it using those prefixes that describe number. Not the case if they're polyatomic ions, and that's why it's really important that you be able to recognize your polyatomic ions. NH4, that's ammonium. That's our cation here in this compound. HCO3, that's hydrogen carbonate. That's the anion. So this is ammonium hydrogen carbonate. Now it's a little long. I may be going to the edge of the screen there. Slide back just a bit. So ammonium hydrogen carbonate. It's acceptable, HCO3 minus charge. It's acceptable to call that bicarbonate as well. So ammonium bicarbonate works there. I think the hydrogen carbonate is a little clearer name, because it's specifying, yeah, this is a carbonate, but it's also got a hydrogen as part of it. Okay, the next one is Ag, that's silver. Now, you may remember we talked about silver really only carries a +1 charge when it's in an ionic compound, and as a result, you don't usually specify the charge on silver. The charge would be +1 here, so phosphate is a 3- polyatomic ion. So each silver atom here does have a +1 charge. So the usual way to name this would be just silver. Pen is acting up on me here. Hold on. Would just be silver phosphate. Right now, because I think it's not, we don't really want to go down the road of having to memorize every charge that's possible for every particular atom. If you want to call this silver 1, I'm okay with that. You should get to a point where you stop using the 1. When chemists talk to other chemists, everybody kind of understands that that's silver 1 by just saying silver phosphate. Okay? But silver 1 would be acceptable on the exam. Okay, the next 4 are a little different. We've got the name. We want to figure out the formula. Now, particularly if you're struggling a little bit with these, I think a good intermediate step here is to just first identify your charges. So we're told right in the name that this is tin with a +2 charge. Right? Now, on your periodic table that you'll have for the exam, all the element names are listed. So it's kind of hard to give you full credit if you use the wrong symbol for something like tin that has a Latin-based name. So, if you call it T, that's not tin. So most people would not recognize what you were trying to describe if you put a wrong symbol into a molecular formula. So make sure you find the right one. You've got the names for all the elements in that periodic table, so take advantage of that. Now, acetate's a polyatomic ion, and the simplest way to write acetate is just kind of the molecular formula, which would be C2H3O2, and that has a -1 charge. Now, the charges here are really what is going to determine how you need to ratio these pieces or units when they go into a formula. Because remember, we're looking for a neutral charge. So if I have a +2 charge from my cation, that means I need to have a total of -2 from my anions. And since I'm only getting -1 from each acetate, I need 2 acetates. So 1 tin, and then acetate's going to go in a nest of parentheses, and the 2 should go outside that nest. This particular problem, it's really not right if you don't have the parentheses. If you just throw another 2 after acetate, that is a confusing formula. Now for this one, you can also write acetate as sort of a more structural formula, CH3CO2, and then the minus would be on there as well. So that's the same compound, 2 carbons, 3 hydrogens, 2 oxygens, just another way to write it. So you could have it in there like that, and you should probably be ready to see it either way if it does show up on a exam, okay? Because it could show up either way, as the molecular type formula or as the more structural based formula. Okay, strontium nitrite. Strontium is in the second column of the periodic table, so it's got a charge of +2. Nitrite is a polyatomic ion. It has a charge of -1. So again, if we take this intermediate step, strontium +2, nitrite is NO2 minus. ITE at the end, that's the designation for the version that has 1 less oxygen than the ATE ended compound. But again, we've got +2 -1 ratio here, so that would mean we want 1 of our cation and 2 of our anion. So that again is going to go in parentheses, and the 2 should go outside of the parentheses. Okay, magnesium nitride. Magnesium is also in the second column, just like strontium, so that's magnesium 2. Now nitride, IDE at the end, that means this is an atomic ion, so it's the ion based on the element nitrogen. And where nitrogen is in the periodic table, it has a -3 charge. So we've got to ratio those charges to get to the correct formula, right? 2 and 3, the first place that we can get an equal number for the cation charge and the anion charge would be 6. So I need enough magnesiums to get to +6, which would be 3 of them, and enough nitrides to get to -6, which would be 2 of them. So my formula should be Mg3N2, right? Now, you really have to understand your suffixes here. When you see ITE, you should know, well, that's a polyatomic ion, there's some oxygens involved, right? How many are there? What's the charge? But when you see IDE, that's when you're going to go look on the periodic table. Okay, the last one here in question 1 Cobalt One Sulfite, so that would be cobalt with a +1 charge. Now watch this second oxygen in cobalt. It should be clearly smaller than the C. So a capital C followed by a capital O is 1 carbon and 1 oxygen. When you're writing cobalt, you want to make sure that second O is small and recognizable as 1 element symbol instead of 2. Sulfite is SO3, and sulfite as well as sulfate have a -2 charge. So this is a similar ratio as we saw in the first two where we're identifying the formula. It's just reversed. The larger charge now is on the anion. So to compensate, we'll have to have 2 of the cations in our formula. So this would be 2 cobalts and 1 sulfite. Okay, we'll stop there with this video. We'll pick up with question number 2 on the next one.